Hello everyone, welcome back to the official YouTube channel of Outlier Research and Technology Center. In this SPSS training video, we are diving into a super important topic, that is outlier detection and treatments in SPSS. The fact remains that outlier can be a serious issue in data analysis, and it can affect the accuracy of your analysis. As a result, it is essential to know how to spot and deal with them properly. So, the question is, what are outliers? An outlier is a data point that is significantly different from other values in our data set or in your data set. For instance, in one of our previous videos, I identified outlier in our data sets. I mean the data set that we are using for our training, this productivity. If you have watched our data video on error checking for errors in SPSS, you will notice that we use a boxplots approach to identify outliers. And the truth is that there are other methods that you can use to identify outliers apart from the boxplots method. Another one that you can use is descriptive approach, and the third one is the Z-score method. So you have three. In this video, I will walk you through the three different methods to detect outliers. The first, boxplots; second, descriptive approach; and the third, Z-score method. So now let us quickly make use of boxplots approach. To detect outlier using boxplots approach, you go to graph, then legacy dialog. From there, from legacy dialogs, you move to boxplots. You click on this. Please make sure you select simple, then summaries of separate variable. Once you do that, you click on define. So this is the boxplots window, and here you can see that we already have two. Okay, when you click on define, you will have your windows like this. This one will be empty, this, and you have all the variables there. So boxplots outliers, we are going to use the continuous data. So we have employees and productivities as continuous data here. So you move the two variables to this box, highlight the two, then click on this arrow to move it to this box. So once you move it to this box, then you click OK. Your results will come up. This is the results window. Here we have results window, and if you look at it very well, you will notice that boxplots mark outliers in both is use both circle and asterisk. This circle denotes that this particular outlier is moderate, but that of star is an extreme outlier. So you should take note of the difference between the circle and the asterisk. Star is the worst outlier. Any outlier denoted by star is the worst, while that of circle is still moderate. You can manage it. So now if you look at employees, you will see that there's no data outside the range, outside the boxplots. But here we have 4 data outside the boxplots, while 2 lies on it here. But okay, let me to have a clear knowledge, a clear view of the boxplots, let me go to graph and only use so I will only select productivity. Let me take out employee from here. Okay, now I have productivity. I want to have a clear view of the boxplots. So okay, now I have the boxplots for productivity. You can now see that there are 4 outliers here. Here everything is considered as mid outlier. So this is the first way and the common way to identify outliers. So this is the first way. The second method is to make use of descriptive approach. So to do that, you go to analyze, descriptive, statistics, then you select descriptives. So here we have several variables. Let's just retain continuous variable. These are the two continuous variables. So we want to check for outliers using descriptive approach. So here now, the next thing, if you want to tamper with this, you can go to options, but I don't need this because I will only make use of the maximum minimum. Those are the two statistics that I need here, the maximum and the minimum. So I will retain the default setting. Then the next thing is you click OK. Then your result will come up like this. This is the result of the descriptive method. Now if you look at it very well, you will see that we have, for employee, we have the minimum to be what? 1, and we have the maximum to be 34. We have the maximum here to be 34. So it is now left for you to go through the data again and see how many ranges between this and this. Okay, here we have 0. You can see, okay, if we have several data around 34, that means there is no problem of outlier. And if you look at it very well, the mean is high in this case, and the standard deviation, which shows the difference, is also a bit moderate. Now if you look at productivity, you will see that the minimum is 0.7 and the maximum is 9. Now how many 9s do we have? So in this case, you go back to the data, then you now look at 9. How many 9s do we have? Okay, this is 1, and we didn't have 8. No 8, that means something is okay. We have 8. Do we have 7? But those are just few. They are just few. This is 7. Do we have 5? We have 5. Do we have 6? But those are very few big numbers. So that means they are likely to be an outlier. But to confirm that those numbers are really outliers, then you make use of Boxplot. The third approach is the Z-score method. You can also use the Z-score method to detect outliers. So to do that, you follow the same approach: analyze, descriptive, then descriptives. But here we need to check save standard values as variables. Save standard values as variables so that SPSS can generate the Z-score for you. So you check this, then you click OK. Now you will see a new variable in your data view. So you go to data view. This is data view. You can see we now have the Z-score for employment. We have the Z-score for productivity. Now the question is, how do I identify outliers using this Z-score approach? Please take note that Z-score only tells you how many standard deviation a value is from the mean. You know, the descriptive analysis will give you the mean, but Z-score will tell you this is the difference between the mean and the standard deviation. You understand? And if you look at employee now, look at all this, look at the Z-score, you will see that there is no one that is somehow big among them. You can see this, we have several ones. But look at Z-score for productivity. Look at it here. This one, 2. Look at this, 1. Again, those are just few large numbers. 3. Those are few large numbers. So they are likely to be what? Outliers. And to check again whether they are really outliers, you make use of Boxplot. But don't forget that Boxplot has already confirmed that case 4, it It has already confirmed that case 21 is an outlier. Let's look at case 21 now. Then you check this, we check this Z-score. Look at case 21, 7. Look at the Z-score, very big, 2.20. And you should also take notes that if you spot any value that is plus or minus 3, that particular value is likely to be an outlier. So when you are looking at your Z-score, just look at those values around 3. Just ignore all this one. Any value around 3, between 2 and 3, between 2, 3, 4 upward, yes, those are likely to be outliers. And if you look at this is 1, it is far from 3, but this one is close to 3, so it is considered to be an outlier. Now let's check. Look at this too. This is 3, so this is certainly an outlier using plus or minus 3 value as a threshold. So this is certainly an outlier, but you can confirm by checking your Boxplot results. So look at 10, observation 10, you see, is an outlier. Boxplot has already confirmed that that observation is an outlier. And again, look at observation 4. So if you check the Z-score, you will notice that it's around 3. This is it. You can see 2.20. So it's around 3. It's also an outlier. And the last one here is 34. If you check the Z-score too, it's going to be around 3. 34. You see, this is even close to, it's very close to 3. So now we have 4 outliers. And if you use a Z-score approach, that is plus or minus 3. If you count them, this is 1, this is 2, this is 3, and this is 4. But the common method of all is Boxplot. So I would suggest, if at all you will use Z-score, make sure you also make use of Boxplot's approach, because most readers are conversant with the reading of Boxplot. For instance, if you use Z-score, now somebody that has never come across Z-score will not know that, okay, let me check for plus or minus 3 values. So please, anytime you want to check for outliers, Boxplot approach is very simple and straightforward. You just check what are those values outside, or the observation outside the Boxplot area. This is the Boxplot. So all these observations are outliers. So now the question is, okay, I've identified the error. How am I going to correct this problem? Well, since you have identified that observation 4 is an outlier, observation 10 is an outlier, observation 21 is an outlier, you have identified 4 outliers in productivity. Now, the next thing you need to do is to investigate and verify if all these values are entry error. You know, it is possible, maybe when you are entering the data, you may enter 7 instead of 0.7. It is very possible. So you check from the questionnaire, you look for the 21st questionnaire, then you check whether the productivity is actually 7.0 or not. If the productivity is 0.7, then you just change it directly to 0.7. And if it is not 0.7, if it is actually 7.0, you may not delete it. Please take note of that. It is not all outliers that you will delete. If you have observation, like in this case, I have other data values for other variables, so I can decide not to delete this. So I will only look for another way to address this issue. So the first approach is you investigate and verify. Next is if you this particular variable, now let's assume this particular respondents also gives values that are outlier here, here, and here. Like you have like 4 different outliers that values that do not align with other values. You can just remove it straight. For instance, here you have okay, this is a continuous variable employee. Here you have 100, here you have 100, here you have 7. You can just remove it because you have 2 outliers for just one respondent. If you have large sample size, you can just do away with it straight. So the first approach is to remove it. The next one is you transform the data. You can transform the data by using log, which is very common. You can just take the log of the whole values. Take the log of productivity. Once you take the log of productivity, a new value will be generated, and that one will certainly serve you well. But that will only be advisable when you only have issues with just one of the variables. For instance, here I have issues with only productivity. So it is advisable I either retain it or take the log. It is not good for me to just do away with it. I can't just remove it. You understand? Why? Because other ones are relevant. They are relevant, they align with other observations. So I can, values. So I can just take the log of productivity to address this particular issue. So first thing is you investigate and verify if these outliers are actually key to your analysis. You just leave them there, then you continue with your analysis. 1 or 2 outliers will not really have much impact on your results. It is only when you have several outliers that's when you can be bothering about, okay, this may affect my outputs. So the next thing is, okay, you remove it if you notice that, okay, this guy did not give the right answers. Okay, here 100 while others are below 50. This participant says 100. You understand? So in that case, you can just remove the whole case. You understand? You just remove the whole observation, then you move on with your analysis. And the third is, okay, you transform the whole variable. You just take the log of everything here. Of course, I will show you how to do variable transformation later. So far in this video, I've been able to show to establish that outlier can distort your data analysis, and also I've also shown you how to detect outlier using Boxplot, descriptive approach, as well as Z-score. In addition to that, I've also shown you how to undo outlier by investigating it, by removing it, or by transforming the whole variable. So please, whatsoever you do here, always document everything, because if you remove a case, you must ensure that the information appear in your methodology. If you take the log of productivity because of the 4 outliers, please let us know in your methodology. You understand? So whatsoever operation you do while cleaning your data, make sure you clearly explain everything in your methodology, so that you will not have issues with how do you do this, why do you do this, why do you use this particular method. Please, if you find this video helpful, don't forget to like, subscribe, and also please hit the bell notification button for more SPSS tip or tutorial. In case you have any question, you drop them in the comment section below. And also, if you want us to address 1 or 2 issues, you can also drop those issues in the comment section. Thank you for watching. See you in our next video.